Lesson 4-5 is linear inequalities. So we have been studying systems of equations, and we need to study system of inequalities. But before we can get to that point, we have to know how to graph and read an inequality. Now, we've already learned how to read it. We've actually already learned how to check them. So our focus today is on how to graph them. Before we do, though, there are a couple of problems in your homework where you have to check a solution to an inequality. And so our first two examples on our notes are just a refresher on how to do that. So how to determine if an ordered pair is a solution to an inequality. You substitute the x and y of the ordered pair into the inequality. You simplify the inequality, and the inequality is true. If it is, then the ordered pair is a solution. Okay, so let's go ahead and practice that. We're going to write out this inequality. We're going to substitute the x and the y into the inequality to see if the left side and the right side make the inequality true. Okay, so y is greater than x minus 3 is our inequality. And we have -7 where the y is, and we have -3 where the x is. Okay, so we did that step one. Now we're going to simplify the inequality. We end up with -7 is greater than -3 minus 3 and -6. Is this inequality true? No, it is not true. Okay, so you would write here, not a solution. Okay. Right. So this part, yeah, this part's pretty simple. You've already learned how to do this. So I want you to go ahead and do example number 2 on your own. Okay, so example 2, the ordered pair 1, 2 is a solution to that inequality. And that's how you check your inequalities. Let's go down to the next section of our notes, how to graph an inequality. So we're going to graph an inequality just like we do an equation, except when it comes to the type of line we draw, and then we also have to do some shading to show all of the possible solutions. So let's look at example 1. We have x is less than or equal to 5. Now this was just, you were just quizzed on this. On our last quiz, you had to be able to graph this. So if I wanted to graph x is less than or equal to 5, what would I do? It's going to cross the x-axis at which point? At 5. So on the x-axis, I'm going to plot a point at 5. Okay, and then I want you to stop right there. It doesn't have a slope. It's going to actually be an undefined slope because it's going to be a vertical line. So we've done steps 1 and 2. Now we have to draw our line. And when we're dealing with inequalities, our lines are not always just straight solid lines. Okay, it depends on what the inequality looks like. So if you look at the explanation here, if your inequality is less than or greater than, then you are going to draw a dotted line. Okay. If your inequality is less than equal to or greater than equal to, you will draw a solid line. So you have to look at your inequality symbol. Since our inequality symbol here has an equal sign under it, this tells us that we're going to draw a solid line. So I will just take my ruler and draw my solid line. Okay. Just like this. But we're not done because the inequality tells us that x can be anything less than 5. It can be 5 or less. The solid line tells us that it can be 5. And now we have to shade our graph to tell us all of the possible solutions to this inequality. So the step 4, in shade your solution, if y is greater than, then you will shade above the line or to the right of the line. Now, above the line is going to be if you have like y is greater than 2, or X is greater than or equal to 3. Okay, if you have a horizontal or a vertical line, okay, if your inequality is less than, then you are going to shade below or to the left, okay? And to the right or the left, these would be like in slope intercept form equations, okay? So that was something that my other classes had a hard time deciphering, and I'll come back to these notes in just a minute. All right, so actually those are switched. Okay, I'll come back to that in a minute. So if X is less than 5, then we are going to shade either right or left. Okay, right would be greater than, left would be less than. Okay, so when you shade, you can just draw lines that look like this if you want, or you could actually shade the entire graph if you wanted. Okay. So if I wanted to check to see if my shading was correct, I could pick any point in this graph along the x-axis, and let's look at -6. If X was -6, is that less than 5?
Yeah.
Yes. So I could choose any point in there to check it if I wanted to. All right, so this is actually not correct. I messed this up. So, okay. So right or left here is horizontal or vertical lines. Okay, I'm sorry about that. I don't like it when I do that because I don't want to confuse you guys. Above or below would be slope intercept lines, or slope intercept equations. Okay. All right, let's go to example. Yes.
When would we use this, like, in life? Not.
That's the daily math question.
Yep, that is the daily math question.
The question of the year. No, that's not. I'm not saying like that. I'm saying like when would we use it? Like what? Never.
No, that is kind of true.
Maybe in statistics, like if you were a business major and you had to deal with statistics, or you were the owner of a business, then you would use this maybe to figure out like possible income or something like that. Okay. All right. Okay. Let's go to example 2. And we are going to graph this inequality. This time though, instead of X, we have Y. So where are we going to plot that -4? On the Y-axis. And this tells us that we are going to draw a line through the Y-axis. However, we need to figure out if we're going to draw a solid line or a dotted line. Which type of line are we going to draw? Dotted. Why? It's not equal to, so we're going to draw a dotted line going across our graph. Okay. And now we need to figure out if we're going to shade above or below the line. So somebody read this inequality to me. Y is greater. So if Y is greater, are we going to shade above or below? Above. Above, you get higher, right? So we're going to shade above. So I'm just going to turn this. Again, you could just draw lines like this. This tells me that you want to shade everything above that line. Oh no. Or maybe they're trying to fix something.
That's all, there's all self-construction.
They are doing a little bit of construction.
Okay, there we go. Now, if I were to pick a point on any point in this graph, okay? I picked the point 3, 6, where my y is the 6. So is 6 greater than -4? Yes, so then this inequality is true, and that would be a solution to this inequality. Okay, let's go to example 3. We have a little bit of a different inequality. We now have an inequality that we need to put into slope-intercept form. And so we need to convert this inequality into slope-intercept form. Okay, so we have 2x minus y is greater than or equal to 3. All right, if I want to put this in slope-intercept form, y equals mx plus b, what is the first thing I need to do?
Move the x.
Yep, we're going to subtract 2x from both sides. And we're left with -y is greater than or equal to -2x plus 3. What's our problem here? Y is negative, so we need to get rid of it. What do we want to do to the equation?
Multiply by -1.
Multiply everything by -1 or divide everything by -1. Either way works. So I'm going to divide by -1. Does anyone remember what we have to do with inequalities when we divide or multiply by a negative?
Flip the sign.
Flip the sign. So now y is no longer greater than or equal to, but it's less than or equal to 2x minus 3.
So whenever you look at the multiply or divide by
Okay, now we're going to graph this inequality. So the first thing we want to do, and this is in your notes on the front page, is that we want to plot our y-intercept at -3. So we're going to plot a point at -3. And our slope is 2, so we're going to rise 2, run 1. Okay. Notice I'm going all the way across the graph. You don't really have to do that. I just like to do that. But when you draw your line, you might want to go across the graph so your shading is more accurate. Okay, now we have to determine whether or not we're going to have a solid or a dotted line. Hi, welcome. What did you say?
No, solid.
Why is it solid?
Because it's greater than or equal to.
Okay, it's equal to. So what tells you if it's going to be a solid line? What is the one little symbol? Because of the equal to, the equal sign. Good. So let's go ahead and draw a solid line. Can you wait? Okay. Now we need to shade. Okay, shading is a little bit different because now we have a slanted line. If you have a hard time figuring out where to shade, you could always use your arm. Now, the front of our notes tells us right here that if it's greater than, you're going to shade above the line. If it's less than, you're going to shade below the line. Now, to me, this is easy because greater means I'm going higher up. And less than means I'm going lower down, like when I think of elevation. So to me, it makes sense. But some people, they have a hard time figuring out what is above and what is below some of these slanted lines. So I will take my arm and I will form the shape of my line. If my line is positive, I form a shape like this. I know this is the top of my arm and this is the bottom of my arm. So since this is less than, I have to shade below my arm, which is going to be, if I were to like plot this down on my graph, I'm going to shade this side of the line. So this is the side of the line I'm going to shade. Okay. So below the line. So this is why I said, if your line is in slope-intercept form, you're thinking above or below. if your line is, or if your slope is 0, you're thinking above or below. But if your line is undefined, you're thinking to the right or to the left, sort of. Okay. Are there any questions on that? Okay, so I'm going to choose a point on my graph. I'm going to choose 5, -2. Okay. And I'm going to plug this into the equation to check my solution. Okay. So when I check my solution, my y is -2. My x is 5. And I need to make sure that this inequality is true. So -2 is less than or equal to 10 minus 3. -2 is less than or equal to 7. This is true because 7 is greater than -2. So I have shaded correctly. If I were to choose a point up here, it would be incorrect. Okay. Yes.
So are you really supposed to check?
I want you guys to try example 4. You're going to have to turn it into slope intercept form and then graph it. And I will have you check your inequality in just a minute. So everybody start working on this. Okay, go ahead and check your inequality to make sure you got the inequality correct. And then once you do, go ahead and graph it. Okay, so this is example 4. Check it. I'm not going to do another check like this, but if you wanted to, you could. All right, and let's flip it over to example 5. And I want you to try this one on your own as well. Okay, this one's from start to finish by yourself. Okay, so this is what you should end up with on example 5. And that's the end of just graphing inequalities. We're gonna graph word problem inequalities in a minute. Okay, I see a few of you still shading. Okay, we're gonna move down to examples 6 and 7. This time we're going to look at graphs that are shaded and we are going to figure out the inequality for them. On this graph right here, it's hard to tell, but it is the bottom part of the graph that is shaded. So if you just want to draw a few lines down here so you know that this is the part that's shaded. It just didn't show up very well when I copied the paper. Okay. So at the bottom, I want you to write 3 things. I want you to write M, I want you to write B, and I want you to write Y. And once we figure out all of these pieces of information, we can actually write the inequality for it. Okay, so the first thing that I want to figure out is my y-intercept. Y-intercept is always easier for me. So what is the y-intercept here? -2. Yep, -2. And then I want to find the slope. So I need to find another box where it crosses an intersection. It does cross right here. So I can find my slope by using rise over run. So we're rising 1, running 1. So my slope is 1. Now, my shading is above the line. So is y greater than or less than? Greater, above is greater. My line is dotted, so is there an equal sign with it? No. So now I can write my equation as y is greater than 1x minus 2. Yep, x minus 2. All right. Okay, so Jaden said this was easy, so I would like for you guys, I want you guys to go ahead and figure this one out. Try to do this one out on your own. Okay, so this is the information and we could write it as y is less than or equal to 2x plus 1. All right, you'll have a couple of these on your homework. Okay, let's move to the back where we have some word problems and we're going to work through these slowly so that you have a clear understanding how to do them. And there are 2 on your homework. Okay. When we write these inequalities out, they will be in standard form and we will need to convert them into slope intercept form. Okay, so I'm going to go through this It says an interior decorator is going to remodel a kitchen. The wall above the stove will be redone in tile, and the wall above the counter will be redone in wallpaper. So the stove is our tile, and the counter, if I could get this cap on, is our wallpaper. So it's good that you're able to distinguish the difference here. The wall above the stove was yellow, is 12 feet squared, and the wall above the counter is 24 feet squared. And the owner can spend $360 or less. Okay. So we need one equation, or I'm sorry, one inequality. And I want you to think about this. Okay, even if you can just come up with one term at a time. Somebody tell me what one of the terms could possibly be. Emma?
We could have 12 T
Mm-hmm.
for our 12-foot square tile.
Okay,
And then we could have 24 W for our wallpaper.
yep. Good. Now, the hardest part for some is this 360 or less. So this is what they're spending right here on tile and wallpaper. Can this be greater than 360 or does it have to be less than? Less than, so less than. Can it be equal to? Yes. So we just came up with our equation, our inequality. I keep saying equations because that's what I'm used to. All right. Now I want to graph this, and there are a couple ways that you can graph this. But we're going to turn it into slope-intercept form, and we are going to isolate the t. So if I isolate the t, what am I doing? We're subtracting 24W. So let's subtract 24W from both sides first. And then we will rewrite this as 12T is less than or equal to negative 24W plus 360. And then what are we going to do? Divide by 12. Okay, and then we're going to end up with T is less than or equal to negative 2W plus 30. And that's what we're going to graph on here. Now, could we have solved for W? Yes, it does. It actually doesn't matter what we solve for. Okay, now we need to graph it. And so we have the confusion of what are our variables? Where do you put them? And does it matter? So now that we've solved for T, it kind of does matter because T is in the place of which variable? Y. Yeah, it's in the place of Y. So your tile is going to be on your Y axis and your wallpaper will be on your X axis. So wallpaper. And then over up here, we're going to put tile. And now we need to figure out the increments. So does anybody know, let's start with the Y here. Does anybody know how far up we need to go? Christian?
Maybe by.
Okay, what are we going to plot on the Y axis?
We can go up to 12 because it's 12 feet.
We actually have to go a little bit higher than that. Andrew? 30, because our y-intercept is 30, so we have to go all the way up to 30. And since my slope is negative, I know I'm going to go down. So we're going to go by 2's on the y-axis. So all the way up to 30.
I'm just gonna go by.
And don't forget to give your graph a title. Tile versus wallpaper. Okay, now the wallpaper on the x-axis, I know that my slope is -2. So once I plot my y-intercept, I'm going to go down 2 over 1. So I could go by ones on my x-axis. Okay. And once you've labeled this, my slope is -2, but notice on my y-axis, I'm going by increments of 2. So when I go down 2 for my slope, I only have to go down 1 box because it goes from 30 to 28. That's going down 2. And then I go over 1, down 2 over 1. And so it looks like you're going down 1 over 1 until you look at the increments on the y-axis and realize that those are going by 2s. Okay, and we're still graphing an inequality. So are we going to have a dotted line or a solid line?
Solid.
Solid. Solid tells us that it could be on that, a solution can be on that line. Okay. And then are we going to shade above or below?
Oh,
Below, because it's less than.
it just shades like that, wow. Okay.
As long as I can tell what your shading is, you're fine. Okay. So
I know it's like a rough shade.
these, so we just graphed a word problem. We figured out the inequality. We turned it into slope intercept. We graphed it. Are there any questions?
What are the prices?
What are the possible prices? That's next. So make sure your notes are readable because you're going to come across when you do the problems on your homework, you're going to want to know what to do. What the first thing that you're going to do is you're going to pick 3 ordered pairs. So I'm going to pick, I'm going to pick 4 and 22. Okay. 7 and 16. And I'm going to pick 11 and 8. Now, what you need to understand with these ordered pairs is that this column right here is representing the wallpaper, and this column right here is representing the tile. So when we plug these ordered pairs into the inequality to check their solutions, we need to make sure we're putting them in the right place. And you're going to have to write small down here because there's not a whole lot of space. But what we have to do is we're going to solve this inequality 3 times, 1 for each ordered pair. Okay, so we're going to write this out. 12t plus 24w is less than or equal to $360. And we're going to plug in our values. So for my first ordered pair, t is 22. So I have 12 times 22. And then I have 24 times w, and w is 4. Okay. So now we need to figure out these values, and I'm going to use my calculator because these are bigger numbers. So 12 times 22 gives us 264. And 24 times 4 gives us 96. And let's stop there for just a second. How much was the wallpaper? Was $96. How much was the tile?
260.
So if this inequality is true, those are 2 possible prices. So when I take 96 and I add it to 264, I get 360. So because this checks out, then I can say 2 of the possible prices would be 264 for tile and $96 for wallpaper, and I'm going to abbreviate wallpaper as WP. And so that's how you would check to find some possible prices within the range that they give you, okay? So let's go ahead and complete this same process for 716, okay? So instead of rewriting the entire inequality out, I'm just gonna plug in my numbers. Tile is 16 plus 24 times the wallpaper, which is 7, should be less than or equal to $360. So just imagine that you're trying to do something like this in your own home and you want to figure out, and you have a budget and you want to stay within that budget. This is something you would use that for. So 12 times 16, 24 times 7, and those total $360. So this checks out. And up here, how much for tile in this solution, in this possible solution? Yeah, 192 for tile and 168 for wallpaper. Okay, I want you to do the last one on your own. Okay, and this would be your third possible price for tile and wallpaper. Any questions from anyone? It was a lot of work, I understand. Just be prepared for that on your homework. There are 2 problems like this. We're gonna do example 9. But this time I want you, we're going to read the problem together, but then you're going to come up with the inequality on your own. Okay. So you and your friends want cake and ice cream from the local cake shop. Altogether, you have $40 to spend. Okay. You want to order cake that is $4 per slice. And you want ice cream, which is $2 per scoop. And I've given you the variables to use, C for cake and R for ice cream. Write an inequality that shows the number of slices of cake and the number of scoops of ice cream you can order. So go ahead and do that. Okay, somebody tell me what they wrote. AJ? Okay, yeah, so you said you had 4C plus 2R. And what did you say? 40. Good.
Oh, I put 2I. 2I. Yeah, for ice cream.
I gave you the variables to use right here. I would be really confusing, especially math, because later you get into something called imaginary numbers where we use a little cursive I. And so
Imaginary numbers.
So
We have letters, but now we have invisible numbers.
yes, not invisible, imaginary. Okay.
That is.
This time, guys, this time you're going to solve for, am I? No. Oh, pause.
Yeah, sorry. I forgot to plug in my Chromebook and it died, so I had to plug it back in and come back.
Oh, that's okay. You guys want to solve for C?
Yes.
Let's solve for,
C.
yeah, let's solve for R. Okay. Shh. Okay, I want everybody to solve for R and get this in slope intercept form. Go ahead and do that now, please. Go ahead and check and make sure inequality is accurate. Okay, any questions? All right, now this one is very similar to the one that we did above. What is going to be on our x-axis? Cake, because C is where the X typically is. So we're going to put cake right here. And then we're going to put ice cream over here. And we're going to title it Local Cake Shop. Oh, you can put it any. anything that makes sense. Yeah, there you go. Cake is yummy.
I'm doing that.
Okay, now let's look at our y-intercept. Our y-intercept is 20. So we can go by twos again up to 20.
Why are we going up by two?
Up by twos. And then we'll go by ones on the x-axis again. Okay, and all right. And now I want you to graph your inequality. Okay, so I'm going to give you a minute to graph. Okay, check your graph, please. And we're going to do the possible prices. And we're going to choose some ordered pairs. Now, I think I'm going to choose some simple ones. I'm going to choose 118. And then I'm going to choose 510. And then I'm going to choose 92. Okay. And remember, all we're doing is we're plugging it into this original inequality to test it out. Now, I didn't leave any space on this one. So because you should be able to do this part, like kind of figure it out. How much if, first of all, this represents cake and this represents ice cream, the R. So all you have to do, I'm going to show you a shortcut to this, is if we bought one slice of cake, how much would we be spending on cake? $4. So $4 for cake. And if we brought 18 scoops of ice cream, how much would we be spending on ice cream?
$18.
18 times 2.
36.
$36
This one makes me easy.
for ice cream.
I was asking kindly, not
Okay.
like,
So I want you to go ahead and finish out and then just total it up in your head. 36 plus 4 is 40. So we're within the range, right? So go ahead and finish the last two. Okay, so check your solutions, make sure they're correct.
this one, and I do not understand.
Hold on just a second.
Is that cake? Right?
Okay, so that concludes lesson 4-5.